Good day, I am Peter Rony. I live in Blacksburg, Virginia. Here is a brief bio sketch. The most important items are my email address and my preferred YouTube search phrase. I've used more characters so it would be easy for you to search for my videos. I am a chemical engineering profession, and right now I'm retired and am a professor emeritus of chemical engineering at Virginia Tech. The title of this video is Buffer and Latch, Microcomputer Input and Output. I need you to distinguish between two terms: an encoding device and a decoding device. An encoding device is required to get information into a microprocessor, and a decoding device is just the opposite. It gets information out of a microprocessor and presents it to you in a... Here is an image that characterizes any of the 10 to 20 billion microcomputer systems that exist in the world right now, 2015. In this video, I will focus on the left-hand function, which is ENCODE. And this function allows you to encode a variety of common information into binary information. And you must have binary information to input into a microprocessor integrated circuit. Now, the decode function here is about the opposite of the encode function. With decode, you take processed binary information and decode it, that is to change it into information with which we all are familiar. I would like to provide you with an analogy, namely an airplane propeller. Now, right now, we have planes with jet engines, but until maybe 2 decades ago, most of our airplanes had propellers. For small planes, just one propeller. For larger planes, 4 propellers. Now, these propellers are mechanical devices, and they do not turn around very quickly. So typical speed is 25 full revolutions per second. This slow rate of revolution can be contrasted with that of a computer, which has and uses clock pulses at the rate of 2,800,000 or triple, quadruple that a number of pulses per second. So an important point in this video is that microprocessors require a series of clock pulses in order to operate. Without such clock pulses, a microprocessor can't do very much. But the technological genius of the microprocessor is that these input clock pulses can occur at an extremely high frequency. Now here's a little bit of jargon. For this video, it really is not important to you, but I'd like to teach you that there are two different types of clock pulses. One is a positive pulse and the other is the opposite, the negative pulses. Also, a group of these pulses has a jargon term, train of clock pulses. Well, that's enough for this topic. Let's move on. Let's get back to the mechanical propeller. Well, here are some examples of propeller speeds in RPM, which means revolutions per minute. And if you divide each of these numbers by 60, you get revolutions per second. The difference between engine speed and propeller speed escapes me, so I will not dwell on the ratio. Now let's look at this table, the clock speed of microprocessors. Well, it started really slow, but once in the mid-70s, the 8080A integrated circuit came out. This microprocessor chip started out with a clock speed of 2 million cycles per second. This is abbreviated as 2 megahertz, capital M, and 1 hertz is 1 cycle per second. Well, since the mid-1970s, the progress in clock speed for microprocessor chip has been breathtaking. Right now, say 10 years ago, the king of the mountain microprocessor chip was called the Intel Itanium, which on average had a clock speed of 1 billion hertz. Contrast that with the 8080, which had a clock speed of 2 million hertz. So when we get into a billion hertz, we really have a fast microprocessor chip that can do almost anything. Now when you begin to learn about microcomputers, the focus is on the computer element and the fact that it compute. And one of the examples is binary arithmetic. It can do binary arithmetic very quickly. But in my opinion, binary arithmetic is besides the point. The key aspects of a microcomputer, and this block diagram represents any microcomputer, small or large, is that we have inexpensive devices called encoders, which translate the analog information, namely the information we are accustomed to using, into binary information. And then we have a variety of decoder devices that perform the opposite function. Something really subtle and is hidden from almost all of you by the terms input and output is the existence of two additional functions. An input function that is called a buffer and an output function that is called a latch. I taught many microcomputer short courses and wrote several microcomputer laboratory textbooks, each of which emphasize the role of a buffer and a latch and how you can build them. So you can ask, well, why do we need the buffer and the latch? Well, let's get back to the propeller blade. And this is a very good analogy. Now, I've shown you an image of 3 blades spinning at a very slow speed of 25 revolutions per second. Well, I'm going to give you a task. Here, the propeller is spinning at its top speed, and I want you to place a blob of putty. Putty is a sticky substance, and I want you to place it on the blade of the spinning propeller. I'm going to give you an even more difficult task. Once the blob of putty is on the propeller, I want you to remove it. And I want you to remove it without getting your hand chopped off. Well, you can imagine that it's really impossible to place a blob of putty on a propeller blade and also to remove it. Think about that. Well, let's get to the easier system of a microprocessor chip. We have the same problem as we did with the propeller, but we can solve this problem very easily. A microprocessor chip needs a buffer, which helps to input information into the microprocessor, and the microprocessor chip also requires a latch, which helps to output information from the microprocessor. Now, the combination of a buffer and an encoder, which actually I called input, is the true input to a microprocessor integrated circuit. And the combination of a latch and a decoder, and I called the decoder here output, is required to handle the processed information from a microprocessor chip. So, do not forget the buffer function and the latch function. So the buffer and latch are hidden from you, and together they comprise the input and output. So here's another version of what I've just shown you. We have an input function which includes a buffer, and we have an output function which includes a latch. Well, there is one inexpensive integrated circuit which is remarkable. Its identification is 74LS373, and you can go to Jameco Electronics at jameco.com and purchase such a integrated circuit for a couple of dollars. And here is what I call a schematic diagram of this integrated circuit. It's a wonderful chip and very good to experiment with it. So what it does is it is intermediate between some mechanical devices called logic switches, and some equally sort of mechanical devices called logic indicators. And data flows from the switches to the logic indicators, which are a form of display. And without going into greater detail about the operation of a microcomputer, I want to stop this video, and I thank you for viewing it. This video has focused only on microcomputer hardware and not on the software which programs a microprocessor chip. Thank you once again.